Jai Hind to all. I am Srivastava, Assistant Professor, Electrical and Electronics Department, Subhati University. So dear learners, today I am going to brief you about the Wheatstone bridge. What is the Wheatstone bridge? It's a device used for the measurement of minimum resistance with the help of comparison method is known as Wheatstone bridge. Wheatstone bridge is basically an electrical circuit where you have to identify one unknown resistance, right? There are some resistors which is connected in that given circuit. You have to first identify one unknown resistance, the value of that resistor, and also you have to make the balance of that particular electrical circuit. So Wheatstone bridge. Wheatstone is basically a scientist's name. Scientist's name is Charles Wheatstone, who discovered this circuit in 1843 approx. And why we called this circuit as a bridge? Because the circuit is connected like a bridge. It looks like a bridge. That's why we say that it is Wheatstone bridge. So basically comparison method is like, one is there are 4 resistors which is connected in this circuit. 2 are known resistors. We know the value of resistor, right? How many resistance which is connected in that given circuit. One is unknown resistor and one unknown resistance, and another is variable resistor, right? So before going on the brief of this Wheatstone bridge, I have to clarify some basic points which includes this bridge, right? So basic key points are resistor, galvanometer and electromotive force, right? Resistor, galvanometer and electromotive force. What is resistor? You all are aware about the resistors. Resistor is like which resists the flow of current, alright? Which resists or control the flow of current is the resistor, and this is the sign of resistivity. This is the sign of resistivity. So resistivity is what? Resistivity is the ability of a resistor to resist the flow of current. It clarifies the ability of resistor, right? So rho is equal to R A by L. R is resistor or resistance, alright. A is the area of cross section of the given material. Area of cross section of given material, and L is the length of the material. Alright, so we can identify the resistivity of that particular material. Alright, next is galvanometer. What is galvanometer? Galvanometer is basically an electronic device. Again, it's a measuring device which measures the flow of current. Alright. So ammeter is also detects the flow of current, but galvanometer detects the direction of flow of current. Alright. So this is a basic electronic device or measuring device. Symbol of galvanometer is G, and how we can measure the galvanometer's value? There is a needle which indicates the direction of flow of current. If the direction is like here, that means the current passes from here to this circuit to this circuit, this point to this point. If the direction is like here, that means it flows from here to here. If there is a null deflection, if there is no deflection in that needle, that means current is not flowing or current is in balanced position in that given circuit. That means this arrow shows null deflection. Alright, this arrow shows the null deflection. That means the current which is flowing through the galvanometer is the value of Ig, the current flowing through the galvanometer is 0. Right? There is a formula for galvanometer is d theta upon di. Right? S indicates the galvanometer, the sensitivity of galvanometer. D theta is basically the change in angle of the needle, and I is the change in current. D defines the change in the current. Alright. Next is electromotive force. You all are aware about the electromotive force. Electromotive force is what? It's the force, it is the force to carry a charge from one potential to another potential, means from high potential to lower potential. The force which carries a charge, that's called electromotive force. Alright, it represents as E is equal to V plus IR. V is volt, the given volt. This is the internal EMF. This is the volt. This is the voltage supplied in that given circuit. I is the current. R is the, this is important, small r is the internal resistance, right? So I am going to brief you the next Wheatstone bridge. So designing of this circuit is like, there are 4 resistors which is connected like a bridge structure. Right? There is a source, a voltage source in the form of battery. Voltage source you can represent as a E or V, plus minus, the terminal of positive and negative. Here is a point A, this is the point B, this point is C, and this point is D. I just connected galvanometer from C to D. Alright. This resistor, the name of this resistor is P, this is Q, this is R and S. So the P and Q are known resistance, alright, and R is unknown resistance, alright, and S is variable resistor, alright. S is variable resistance. That means we can vary the resistance of this particular resistor. This is the variable resistor. Alright. This is the circuit of Wheatstone bridge. Next, the current starts flowing in this bridge from positive to negative terminal. You can use the Kirchhoff law, right? Current flowing from this circuit to this circuit, from this line to this line. Here, what will happen? Current divides in 2 parts. One is here, one is here. It's I1 and it's I2. Alright. Next, what we have to prove in Wheatstone bridge? We have given this circuit and we have to prove this is the balanced circuit. We have to prove that. Alright. We have to identify this unknown resistance. So this is, we assume that this is the balanced circuit, and balanced circuit, that means this is Ig, current flowing through the galvanometer. So Ig is equal to 0. Alright, we assume that. And this circuit should be like what? P by Q is equal to R by S. This should be. We assume that and this should be. So we will going further to prove that. Alright. So I1 is flowing through this P resistor, I2 is flowing through the R resistor. What will happen here? Ig is equal to 0. We assume that this is the balanced circuit. That's why no current is flowing through the galvanometer. That means galvanometer is showing what? Showing null deflection. Alright. So what will happen here? Current directly flows through the Q resistor. So current is I3 which is directly flowing through the Q, and what will happen here? Same current is not flowing in this galvanometer. So here is I4. Got it? Next, let me check here. I1 is flowing through this, I2 is flowing through this. So if we can check here, I1 should be equal to I2. Got it? I1 is equal to I2 because it divides in two parts. So I1 P is equal to I2 R. Right? I1 P is equal to I2 R. I1 P is equal to I2 R. Then I1 is equal to I3 and I2 is equal to I4 because same current is flowing through this resistor and same current is flowing through this resistor. Alright. So I1 is equal to I3 and I2 is equal to I4. I1 is equal to I3 and I2 is equal to I4. This is the equation number first. Here you all are aware about this formula, right? So how you can identify the value of current? I is equal to V by R. Alright. So I1 is equal to or I3 is equal to V1. What is R here? R is P and Q, resistor. Resistance are P plus Q for both I1 and I3. And here V upon I2 and I4, R and S. Alright, R plus S. This is equation number 2. This is equation number 3. So put equation 2 and 3 in equation 1. What will happen? I1, I will put this value V by P plus Q into P is equal to I2 V by R plus S and I2 is equal to R. Alright, got it? Next, it's basically Vp by P plus Q is equal to VR by R plus S. Alright. Next, what you will do? Vp R plus S is equal to VR here P plus Q. VR P plus Q. Alright. So V, you can cut it. PR plus PS is equal to PR plus QR. So if you put this PR here, if you carry this here, so what will happen? This is positive, this is negative. PS is equal to Q R. So as starting, you have seen that we have to identify the R, because R is unknown resistance. Got it? R is unknown resistance. So R is equal to PS by Q. This is the Wheatstone bridge which identifies the value of R if you have this given resistance. Alright? So the application is like basically to identify, to measuring the accurate value. Sometimes it identifies the temperature, it detects the heating amount or the temperatures, the different types of measuring instruments it used that. Due to it gives the precise and accurate value. So we use this Wheatstone bridge is in different types of applications using sometimes operation amplifier, right? So I think you all are just gone through all these derivations and Wheatstone bridge, so you got the point how you can identify the R as an unknown resistor. Alright, so we will discuss further some theorems in next chapter. Meantime, alright, thank you.